Alright, lovely people. Let's look at another way we can approach differentiation. Because it's not in all cases that you will be asked to differentiate or find the first derivative or anything. Remember, the question can be twisted. It can ask you to find the rate of change for a given interval. They are also asking for the derivative. They can also ask you to determine the gradient of a function. The rate of change of a function, the gradient of a function, they are still talking about the first derivative of that function. Now let's use this equation to illustrate. Here they are asking us to determine the gradient of this function at x equals to 3. The interpretation of this, determine the gradient, they are asking you determine the first derivative of this function when x is equals to 3. When x is equals to 3. So the normal approach for differentiation is what we are going to go through. First of all, before we can differentiate, remember, before you can differentiate, you should always simplify first. So let's get rid of this. This is 3 times 2x squared. 3x times 2x will give us 6x squared. And we have 3 times this, we have minus 15 over 2x squared. 15 over 2x squared. And they want us to find the first derivative of this function at x equals to 3. Now, what do? This is 6x squared. This is 15x over 2. What do? We find the first derivative first. Now, the first derivative of this, remember the formula is if we have f of x is equals to x to the power of n, the first derivative will always be multiply the exponent with the coefficient and subtract 1 from the exponent. So the first derivative here will be 2 times 6, which is 12, x to the power of 2 minus 1, which is 1. Minus the first derivative of this will be 2 times 15 over 2. And that will give us 15, and we have x 2 minus 1, and that is the first derivative of this function. They didn't just ask us for the first derivative or for the gradient. They said when x is equals to 3, what will that be? So when x is equals to 3, we will now have the first derivative of this function at x equals to 3. That means we'll have 12 times 3 minus 15 times 3. This gives us 36 minus 45. 36 minus 45. So the gradient of these at that point, the slope or the gradient or the rate of change of x, y with respect to x at that point will give us 9. So what is the interpretation of this? If we have this function, it is 6x squared. So let's say we have something like this function. It doesn't represent this expression, but I'm explaining this. So it means that the gradient or the slope at that point when x equals to 3, will be 9. And you can use it to get the value of the slope at that point. So this is the representation that we've gone through. Please continue to follow my pages, continue to subscribe to my channels, and don't forget to share.